Yeah, dude, you can pull it out.
Oh.
Go ahead. What's the numbers?
Like, from the black arrow?
What's the line up with that?
Oh,
The
40.
center line of the...
It's 40. 39.
Okay.
Mm-hmm.
Okay.
Yeah, so now it's like
So where do you read it from?
the bottom one?
That's a good, yeah, either side. See either of those green lines on the
So
compass.
it's like 44?
Good. Yeah. With dip, Hannah, what you want to do you want to do the strike first or?
No, it's okay.
No, okay. With dip, see that black arrow in there?
Mm-hmm.
That's what you're trying to move into, or that's what's going to give you the numbers. So when it's basically horizontal, when the dip isn't running anywhere, that black arrow should point to 0. So you want this edge to basically be placed on your bedding plane such that it's parallel to which way the water is going to run.
So
So like that. Yep. So perpendicular to the strike, and that's going to be your dip. And now you're looking at the black arrow and what number it points to. What's that?
that's 12.
Yeah, that sounds right. All right, so now we know that there's shale there, and we know that it's dipping towards the south, which in this image is back towards where we started, right? So it's dipping back into this hillside and where we started up at 1B. And this is shale. And up there was sandstone, or Tuscarora sandstone specifically. And the question then we have to think about is, relative to the stratigraphic column, what other rocks are supposed to occur between the Tuscarora sandstone and the shales? So looking back at the stratigraphic column, we see the Tuscarora sandstone is here, and the shales are these Reedsville and the Antes Gap shale. So you had Juniata and Bald Eagle that occurred in between. Notice that the Bald Eagle is a conglomerate and a sandstone, and Tuscarora is a sandstone, whereas the Juniata is a siltstone, and then these shales are small clastic material that weather fairly quickly. So maybe that's explaining why we have those differences in elevations. Interesting. And then if that's the case, then these limestones, the OLST, right, any of these limestones then we would expect to be further out into the valley, because now we've done our job. And just as I presented at stop 1A, we verified that this geologic map makes sense. We've seen that the Tuscarora sandstone is up here at stop 1A, and that as we went down the hill, we got to the ORAs, the shales, okay? And we didn't verify, but we expect then that the OBE and the Juniata, so the Bald Eagle and the Juniata were in between. And out in the valley then are these limestones. So from the stop 2, the shale pit, we then drove down this road, and I had everybody looking out towards this ridge. And we talked about the fact that right here, you can see a gap in the near ridge. So remember from above, we could see where those gaps were, those truncations in the ridge, and I asked the students to watch why that was the case. Well, we drove down the road, and hopefully you can see that there's a low elevation right here. And then what happened was we got really close between the road and that low elevation, and we could see that was a stream. So there's a stream that comes running out of that valley, or running out of that low elevation in between the ridge, the gap, and it delivers water down into this valley, okay? And then we took the bus down along this road still, and right here we noticed there was another gap in that ridge. So sure enough, there was another stream coming down. It's kind of hard to see on this map, in this image, but I can definitely tell you it was running right in there next to the road.